Welcome to the Explore Composites Materials Library. This is laminate sample number 25. This one is a plate of infused e-glass with vinyl-ester resin. The material is a very thick 54-ounce stitched material, and it's got 6-ounce e-glass on the faces. It's going to look like this when it's infused. Here's a look at the material. This is a 3-weave. It's stitched 090, and it's really just a bunch of layers of biaxial stitched together. And here's the whole stack, including the 6-ounce woven. And I'm going to clean the table off here. This is getting laid up on adhesive Teflon, so the surface won't be awesome, but it's quick and easy. First ply down, I'm going to put some nylon uncoated peel ply, and this will just be an example of one peel ply on each side, each face of the plate. And the first ply down is a 6-ounce woven, just a plain weave, and this is the 3-weave material. It's 54 ounces, it's very heavy, feels almost like carpet, and it's 090 material, and a bunch of it's stacked up, so the fiber toes are relatively small, but they're a bunch all together, so it's really like 3 or 4 plies of biax stacked up and stitched. And I'm just dropping it down 090, so this will be a relatively balanced plate with no fiber in any direction but 090, and get some tape on the edges that I don't want to get off. And on the top, just another 6-ounce / 200-gram plain weave e-glass. And on this top skin, I'm going to use Compoflex, which is an infusion flow media and peel ply all in one. I've got to cut it to the right size. This is great for infusion, and it's, in theory, is also a peel ply. Now, because I've never used it here, I'm going to cut it to the right size and then think twice and chicken out and put down a bit of coated peel ply just to make sure. Turned out this was totally unnecessary. What I really needed is some sharper scissors. So now I'm going to put the Compoflex down. It's not acting as a peel ply really here, but the yellow on top is a infusion flow media. And for the vacuum side here, just a piece of peel ply wrapped around some spiral wrap. It's about as straightforward as it comes. A nice big vacuum break there, all that peel ply. And on the resin inlet side, same thing, peel ply wrapped around, and I'm going to make sure that butts up against or laps over the Compoflex, so the resin will have a chance to flow from the bucket in and transfer into the flow media really easily. Here's the vacuum bag. So I just did a quick wipe, cleaning up any loose fibers that would get under the sealant tape. Bag is plenty big enough for some pleats. And here I'm not going to do anything fancy, just going to stick the hoses for the vacuum and for the resin through pleats in the bag and suck it all down. Trying to make the bag as flat as possible, no wrinkles and stuff over the actual part, because the wrinkles can let resin run. So here it is all bagged up on the warm table, and there are some pleats showing the vacuum hose through the bag. It's important to put them up in pleats, or else they could pull the tacky tape up as you're handling them. And there's the inlet hose overlapping the Compoflex. So I'm going to mix up some resin here. This is a Vinyl-ester infusion resin. It's very thin, almost watery. And this is the catalyst. I'm going to catalyze it about 1.5% because the table is pretty warm and I don't want to overdo it. It turns out I could have catalyzed it probably less. I ought to have had the table a little cooler because I think when it cured pretty hard, and there was a little bit of either interlaminar delamination, micro cracking, whatever, just because it was thick, and there may have been some shrinkage in there that I should have avoided. So I'll just let that set for a little bit. Once it's degassed itself, put it in my little holder, which is just a pot screwed to a piece of plywood. And see, the temperature, 86 Fahrenheit, it's pretty warm, and the vacuum is about 300 millibar, which is nowhere near full vacuum. I'm just doing that to kind of test how it works and also keep it under the vapor pressure that would pull off any volatile MEKP. And so here it goes. I've opened up the valve. This is a very thin resin and it flows super fast. You can see the flow front moving through the Compoflex. It works really well here. But one nice thing is that the resin doesn't get too far ahead in the flow media compared to where it is in the plate itself. And the Compoflex will still carry air out that comes from behind where the flow front is. And watching it go across there, it doesn't race way ahead. And you can see out in the perimeter where the green peel ply is that the flow at the bottom of the plate is not too far behind the front, down on the table surface. You don't want too much of a wedge where the bottom is lagging behind because the top can overrun it. And see, that's about the extent right there in the red circle of how far ahead the flow front is. And so this filled really nicely, and all around the edge you look at it and it was really clear. And it hit the end of the flow break here, and you can see it catch up nicely. This material seems to pack really well because the 3-weave material, the fiber toes aren't that big, and they really jam together. And there it is full, and I'm taking some pictures of it, clamping it off, and I'm just gonna leave the vacuum as it was. And I'll let this gel. It's nice and clear, there's no air, and this is before the part started to gel. So I came back after several hours. It had gelled really hard, and took the tacky tape up, all of the consumables off, flipped it over and had a look. You can see some shrinkage in the surface. Of course, it's got peel ply on it as well. And there goes the Compoflex. I had nothing to be worried about. Peels off beautifully. And of course, this peel ply does as well, leaving a nice surface. I probably should have let this cure a little bit more. It seemed a little green when I went to pull this peel ply off. This one came off much harder and left much more sort of white, disturbed surface. And here I could peel off a little bit of the woven on the bottom. This is a very heavy panel, 2 pounds, 3 1/8 ounces, or 996 grams per square foot. And taking a look at the thickness, excuse my camera work, but it's relatively consistent, within about 0.2 millimeters thickness across. It's a little bit thicker on the side of the resin inlet, which is to be expected, but overall thinner than I had predicted. Here's a look at the panel, trimmed, very compact looking, very dense. There's a lot of fiber in there and not an awful lot of resin. I guess that's good. This is about the minimum that you'd really want to look at for resin content. You can see the edge, the trim bit there. It's a nice solid plate. And talking about fiber volume fraction, this is a very dense glass and not a very dense resin. And you can see, despite the high weight fraction, the volume fraction is only about 50-50. So having a look here, held up to the light, it's a pretty nice panel. This would be useful for a lot of stuff. I'm not sure the 54-ounce material is an improvement over more plies of thinner stuff, but it's interesting to look at either way. Thanks for checking it out.